Here we go, and here's the warm-up for lesson 3. So just a reminder that lesson 3 is quantiles of k value. So finding the x value if you are given the area under the curve, so the inverse norm lesson. So again, let's warm up first. So we've got Jack. Jack decided to collect money for charity. His average weekly collection is approximately normally distributed with a mean of $60 and a standard deviation of $5. So we can write out our mean, this mu symbol, is equal to 60. And we can write out our standard deviation is equal to 5, according to the question. So in a randomly chosen week, find the probability, so as a decimal, of Jack collecting between $50 and $63. So remember his mean is 60, so the mean is at 60. So $50 would be a bit to the left and $63 would be a bit to the right of the mean. So you can mark in these areas and we can shade them in. So find the probability. You can just plug it into a calculator if you like. So let's do that. Let's open up the calculator. So do you remember what to do? You would go second vase. Normal CDF, so select the second option. What's our lower bound? Our lower bound is this number here, so $50. So we can type in 50. Let's type in 50 there. Our upper bound is the higher bound, $63. So let's type in 63. Our mean is $60. And our standard deviation is 5. That's going to help us find the area under the graph, which is also the probability. Press paste. So what would that be to 3 sig figs? That would be 0.703. Again, write it out fully, but then round to 3 sig figs is what I would suggest. So that's a probability that Jack collects money between $50 and $63. In a 52-week year, in how many weeks would Jack expect to collect at least $67? Okay, so this, remember, is his weekly collection. So this is like an expectation kind of problem. We've got to calculate the probability first and then multiply it by 52 to get how many weeks. So at least $67. So if you were to draw the curve, it would be a little curve like this. And the mean is at 60. So $67 would be to the right. So at least $67 means $67 or greater. So think what would be our lower bound? Our lower bound would be 67. What would be our upper bound? It would be positive infinity. So remember how we put that in? We go 1e99. And then that's to work out the probability. So let's work out the probability first of all with our calculator. Let's do that. Go second vase. Select number 2, normal CDF. Our lower bound is the 67, so let's type in 67. Our upper bound is positive infinity, so remember we put that in as 1 second comma to make E99. 1E99. Our standard deviation is still 5 and our mean is, 60. Standard deviation is still 5 and our mean is still 60. So we can go on to paste. So what's our probability? Our probability is 0.0807 blah blah blah. So don't round that yet. So write it out unrounded first of all. So 0.080756 ... So we've got our probability and we want to work out how many weeks. So you multiply the probability by the number of weeks. So multiply by 52 to work out how many weeks. So it's not going to be many, as you can see it's a small area. So that would be 4.199 weeks if you take that probability from the calculator, times it by 52. So yeah, let's see what happens if you do it on the calculator like this, times 52. So you get the answer, 4.199 and so on, ... So which is approximately 4 weeks. So assuming we have to round to the nearest week. So around about 4 weeks in a year, we'd expect Jack to have collected at least $67. Now here's another question about Portuguese man o' war. So some Portuguese man o' wars have washed up onto Southland's beach after a storm. Their lengths have a normal distribution with a mean of 22 and a standard deviation of 3.4. So let's write out our mean. Mu is equal to 22. Standard deviation is equal to 3.4. Always good to write them out. So if a man o' war is randomly selected, find the probability that it is at most 20 centimeters long. So remember the mean is 22, so that's through the center. So 20 would be to the left of 22. And they say at most 20 centimeters long, so meaning 20 centimeters or lower. So they want to know, what's this probability here? What's this area under the graph for 20 centimeters or lower? So try to think what would be our lower bound. Our lower bound would be -1e99. Our upper bound would be 20. We want to find a probability. So let's go second vase to normal CDF. So our lower bound is -1e99 to do negative infinity. Our upper bound is 20. Just make sure you're typing in the right numbers. Our mean is 22. It's useful to just have it all written up there. Our standard deviation is 3.4. Just check you've got all the right numbers. And press enter. And as a probability, you get to 3 sig figs, that would be 0.278. So that's the probability. Oops, went that one there, 0.278. I'll just undo that. There we go. 0.278 for the probability. Find the proportion of man-o-wars, so that could be a probability or a percent, between 19 and 25 centimeters long. So again, the mean, do your little sketch of your normal distribution. The mean is at 22, according to our question. So 19 would be a bit to the left, and 25 would be a bit to the right. So it would be this area here, and you need to put in your lower bound as 19 and your upper bound as 25. So let's go back, clear second vase. Normal CDF, select the second one. Our lower bound is 19, according to the question. Our upper bound is 25. Oops. So yeah, again, just check you're definitely putting in the right numbers. 25. Mean is still 22, and our standard deviation is still 3.4. Let's plug that in, and we get 0.622. You can write 0.622, because proportion, it's pretty open in terms of what it means. Could be a decimal or could be a percentage. If you want it as a percentage, just times by 100. Times that by 100, you get 62.2%. Makes about sense. You'd expect that area to be around about that much. Lastly, for this one, question C, but it says D. How many man-o-wars from a sample of 500 would you expect to measure at least 21 centimeters? So this is where we need to work out the probability first, and then times by 500 to work out the expected number of man-o-wars. So at least 21 centimeters, again, remember our means at 22. So 21 would be to the left, so mark in that line there. And at least 21 centimeters means higher. So this area to the right. So again, our lower bound would be 21. Our upper bound would be positive infinity. So let's plug that in. First of all, let's get our probability to begin with. And then we'll multiply that probability by 500 to work out how many man-o-wars. So 21 is our lower bound. Our upper bound is 1e99. And the rest is all still the same. So we get a probability of 0.616, or we shouldn't round it at this point because we want the unrounded answer at the moment. 0.6156 ... 566 ... And so that's a probability, unrounded, and we want to work out how many out of 500. So take your probability and times by how many man-o-wars there were. So times by 500, so 0.61566 ... times 500. So just put times 500 in the calculator to work it out. And how many man-o-wars? You get like 307.8 something. 307.832 ... So what have I rounded it to? That's about 308. So 308 man-o-wars. We would expect to measure at least 21 centimeters because it's more than half. So it should be more than half according to our probability and according to our diagram as well. So now let's move on to the lesson. Lesson 3, quantiles of K values. So basically it's the inverse step. Beforehand we were calculating what is the area if you know the boundaries. Now what we want to know is if you're given the area, what is the boundary, like what is the X value? So this section is the opposite step of what you did in lesson 2. That is, this time you will be given the area under the graph, which is the something starting with P, the probability. And you'll be asked to instead find either the upper limit or the lower limit. K. So basically finding the X value. So for example, let's have a look at an example. And we're using our calculator a lot for this as well too, so if you haven't got your calculator out, pause it and grab it now, please. So for example, if x is normally distributed with a mean of 56 and a standard deviation of 2.1, find the value of k for which x is less than k, for which basically the probability, the area under the graph, is 0.4. So two things we can write out from this information, that the mean is 56 and the standard deviation is 2.1. Remember, it's not 2.1 squared, it's 2.1. Radio, and we've got this little picture down here. So it's basically saying that if the area is 0.4, area that x is, the probability that x is less than k, meaning that the area to the left is 0.4, so clearly it's got to be to the left of the mean, because remember the mean splits it into 0.5 and 0.5 areas, half and half. So 0.4 area must mean that k is somewhere to the left of the mean. So notice you've already been given the area under the graph. They've told you that this area is 0.4. Which in this example is equal to, as we said, 0.4. They want you to find the value of the quantile. Basically, what is this k value? What is the upper boundary? Which is the upper limit. So as we said, so they want you to find the upper limit. You can see the lower limit is negative infinity. What is the upper limit going to be? And that's what the calculator is going to tell us. The lower limit will be, as we said, negative infinity, or in the calculator, negative 1e99, because you can see it goes all the way back here. The upper limit is k. So it's always good to try to roughly sketch the normal distributions to get an idea of where things should be placed. So try to sketch in roughly where the quantile k would appear, and we decided it would be a bit to the left. So kind of showing you down here as well. It'd be to the left of the mean, because if the area, this shaded grey area, is 0.4, that's got to be less than 0.5. 0.5 is this whole left part. So 0.4, it's got to be, means that k value, the little boundary, the upper boundary, has to be a bit left of the mean. Shade the area to the left of this point. Bear in mind that the area under the entire curve is always equal to, what's it always equal to, the area? It's always equal to 1. And that the areas to the left and right of the mean are always equal to, what's this whole area to the left of the mean equal to? Yep, it's 0.5. And what's this area to the right of the mean always equal to? It's the same, it's 0.5. This will help you to work out roughly where k was. So if they said the area was 0.8, then of course k's got to be up here to the right somewhere, because then it would be more than 0.5 of the area shaded. But if it's 0.3, then k's got to be to the left, because it's got to be less than 0.5 of the area shaded. And so on. Alright, so let's move on from there. So how do I use my GDC to find the value of this upper limit k? So like in lesson 2, as this topic is the normal distribution, look for the word distribution on your GDC again. Let's clear that. So it's back here, it's still just a vase. So that's why we always do second vase, because it opens up distribution. So second vase. Remember, we never ever use the first one, so ignore it. You should see this list, and the one we use to find the upper boundary is the third one, inverse norm. Number 2 is for finding the area, or the probability, which we did last lesson. Number 3 is for finding what is the boundary if you're given the area. So see inverse norm, number 3. So as you were doing, what you were doing now is called the inverse, like the reverse step. You're given the area and you're instead asked to work out what the upper boundary is. What option do you think you select? Because it's the inverse step. Yep, it's inverse norm. We're selecting the third option, inverse norm. So we're going to be doing that throughout this lesson. So the process so far has involved you selecting second, vase, and number 3, inverse norm. So second, vase, 3, inverse norm, inv norm. These prompts should then appear. So we'll show you, let's demonstrate. So when you go back to the beginning. So go, oops, second, vase, inverse norm, you can just go straight to selecting the third option that operates it. You've got to plug in the area. The area is what you would have been given in the question. Like in that last example, the area was 0.4. And then the mean, you've got to plug in what the mean is, and you've also got to plug in what the standard deviation is. So notice that the area under the graph has to be the area that's to the left of k, not to the right. But you can, if you're given the area to the right, it's easy because the whole area is equal to 1. So if the area to the right is 0.3, the area to the left must be 0.7. if the area to the right is 0.6, the area to the left must be 0.4, and so on. So the area, so mu is the mean, sigma is the standard deviation, as we already know that. So now let's move on to the next page. And actually let's try applying one so we can learn how to do it properly. So back to the original question, if x is normally distributed with a mean of 56 and a standard deviation of 2.1, find the value of k for which the probability, the area, that x is less than k, meaning this area here, is equal to 0.4. So we know our mean is 56, our standard deviation is this number here, 2.1. So the area, they told us it's 0.4. They already told us the area to the left, because the probability that x is less than k, so meaning to the left. If they said probability x is greater than k, that'd mean this area to the right. But we've already got the area to the left, so the area that's plugged in has to be the area to the left. 0.4, mean is 56, standard deviation is 2.1. So if you plug this into the calculator, it's going to tell us what that upper boundary here is. So let's do a demo of that. Let's put in 0.4, 0.4. Let's put in for the area 56 for the mean, standard deviation is 2.1. Go down to paste. See, this pops up and you just press enter again. So what would that be to 3 sig figs? That would be 55.5. 55.5. So what that has told us is they've given us the area already. So we've just found out what the upper bound is. You can see already the lower bound is negative 1e99, negative infinity. This upper bound here, so this point here, would be 55.5. And that makes sense because the mean is 56, so it should be a value to the left, 55.5. If you had came up with 60, that would be wrong because 60 would be to the right of the number of the mean. But this one makes sense because it's to the left of the mean. Let's do another example. The university professor has decided that 10%, so if that was an area under the graph, remember percent to turn them into a probability, divide by 100. So the area is 0.1. University professor has decided that 10% of students will fail the examination this year. The examination results were approximately normally distributed with a mean of 68 marks and a standard deviation of 11. So let's write out mean is 68, sigma is 11. Find the minimum mark required to pass the examination. So it's always a really good idea to do, if they won't give you these hints in the exam, but it's a really good idea to do these sketches. Roughly sketch the area which represents the failing students. So do your normal distribution, mark in your mean, 68. So 10% of students are going to fail. So this shaded area is representing the students that will fail. So what they want to know is what's the minimum pass mark, what's the lowest pass mark. So if you're in this unshaded area, it means you've passed. So what's the lowest mark you can get? It must be that little boundary there, the upper boundary. So the area, and it has to be always the area to the left of the boundary that goes into the calculator. So what area do we have here? We have 0.1. So our area is 0.1. Plug in your mean and standard deviation. So remember we've done this on the calculator though. So we've gone second vase, select the third option, inverse norm. We've got our area as 0.1. I should put it in a bit better than that, 0.1. Let's put it in properly. 0.1. Mean is 68 and the standard deviation is 11. Paste, inverse norm. There you go. So we've got the value of this upper bound here. So the pass mark, the smallest pass mark possible, you could still get a high mark and still pass, but they want to know what's the smallest mark possible to be able to pass the exam. It'll be 53.9. So the value of the quantile k, which marks a possible passing mark, is 53.9 marks, according to this question. Which again makes sense because 68 is the mean, 53.9, it should be somewhere to the left. So it is, that's good because it's less than 68. Let's go into the next question. So as it turns out, the GDC will only tell you what the upper limit is, like they won't tell you what the lower limit is. So therefore you need to always make sure that the area you enter is to the left of the point K. So don't enter the area to the right, you've got to enter the area to the left. Remember that's easy to do because the area under the curve is always equal to 1. So if they've told you that this area is 0.3, then the area you'd have to enter in the graph is 1 minus 0.3, so it would have to be 0.7. If they tell you this area is 0.2, then the area you put in the graph in the calculator should be, 0.8. If they tell you this area is 0.15, the area you should put in there is 1 minus 0.15, which is 0.85. So if you're told that the probability that x is greater than k, meaning that this area here is 0.3, and x is normally distributed with a mean of 23 and a standard deviation of 1.5, sketch this area on the diagram below. So they're saying that x is greater than k. So here's k, talking about the area greater than k, not less than k. So shade the area greater than k. So our area is 0.3. We know the mean and standard deviation. We can still work out what k is just by plugging in instead the area to the left. So 1 minus 0.3, 1 minus 0.3, as we said, it's 0.7. So that's the area to the right, so the area to the left would just be 0.7, and you would have to plug that into the calculator instead. So down below it's asking us to mark in what we would do. We'd have to press second vase 3 inverse norm. The area we'd have to put in is the area to the left of k, which if the area to the right is 0.3, we have to put in 0.7. Our mean we got up from here, 23, and standard deviation is 1.5. Plug them into the calculator just like so, and it should hopefully spit out the answer, which is 23.8. So it's telling us that this value k is 23.8, which makes sense because 23 is the mean. 23.8 is higher than that, so, and it's to the right. So let's keep going. Some more examples on the next 2 pages. So suppose that x is normally distributed with a mean of 38.7 and a standard deviation of 8.2. So write them out. Always is very helpful to have that written out there, especially when it comes to plugging it into the calculator. Illustrate with a sketch and find x such that probability x is less than k is equal to 0.9. So when they say x is less than k, they've given you the area to the left, so that's good. Here they're saying x is greater than k, so they've given you the area to the right, so you'll have to plug in the area of 0.2 instead. So let's do a little sketch. Probability that x is less than k is 0.9. So that means that almost all of the distribution's been shaded. K would be somewhere right up here, because 0.9 area has to be to the left of it. So a little thing of 0.1 is to the right, but in the calculator we have to put in the area to the left. So just demonstrating what we'd put in the calculator, we'd go second vase 3 inverse norm. Area to the left is 0.9, so 0.9. We have to put in the mean of 38.7 and a standard deviation of 8.2. Enter, paste, enter. 49.2. So k, this little upper bound here is 49.2. You can already see what the lower bound is, but they want to know what this upper bound is. So if they change it, now x is greater than k. So try to think, what would be the area to the left of that? Oops. Area to the left of k is 1 minus 0.8, which is 0.2. So they've told us that the area to the right of k is 0.8. So k is down here somewhere. There's our k. So k is down here. The area to the right of it, because x is greater than k, is 0.8. So what would be the area to the left of it? It would be 0.2. It's just 1 minus 0.8. So in your calculator, you would have to enter these things again. Okay, so let's clear that. Second vase 3 inverse norm. Let's put in our area 0.2. We've still got the same mean and standard deviation as before. So the upper bound would be 31.8, rounded to 3 sig figs. Again, it makes sense because your mean is 38.7, so our k value should be something less than that. So 31.8 is less than that. Now let's move along. Suppose x is normally distributed with a mean of 30 and a standard deviation of 5. So mean of 30, standard deviation of 5. Here's a diagram. Determine whether A is greater than or less than 30. So our mean is 30. What they've said here is the probability that x is less than A is equal to 0.57. So draw your normal distribution. And 0.57, it's more than a half, isn't it? It's more than 0.5. So 0.57, it's more than a half. So here's your mean of 30. So if the area to the left, so x is less than A, the area to the left is of A is 0.57, then A's got to be a bit to the right of the mean, because it's got to have 0.5 plus another 0.7. So 0.5 is to the left of the mean, the area under the graph to the left of the mean, so you need a little bit just to be slightly right. So A's got to be marked into the right of the mean. So use technology to find A. We've already been told the area to the left, we're all good, so we just have to enter in the area 0.57. So let's go second vase, 3 inverse norm, 0.57, and our mean is 30, our standard deviation is 5. Let's see what we get. We've got our upper bound as being 30.9. So 30.9 would be our upper bound. A is our upper bound, as you can see. Then without using technology, find the probability that x is greater than A. So if this whole area here is 0.57, what's this other unshaded area got to be? And that's easy, because remember the whole thing's equal to 1, so you just do 1 minus 0.57. So 1 minus 0.57, you can plug it into your calculator if you like, you get 0.43. Plus also they want to know what's the probability of it being between 30 and A. So 30 is the mean anyway. So if this whole area is 0.57, and you know what this area to the left of the mean is 0.5, then clearly this little area here has just got to be 0.7. Does that make sense? So if you want to show working out, you can go 0.57 minus 0.5 to erase off this part. Leaves you with 0.7, 0.7. Just showing that on a diagram there, because they want to know what that area is there, 0.7. So 0.57 minus 0.5 gives you 0.7. Okay, so let's do some more examples down here. I've kind of got these written in because particularly this last one's a bit tricky. So given that mean x is normally distributed with a mean of 23 and a standard deviation of 5, find the probability x is less than A. So find A such that, sorry, A is basically find K, or find the x value, such that x, the area to the left of the graph, when x is less than A, is 0.378. So it makes sense if you draw your normal distribution, put in your mean, and the area is less than 0.5, so the A's got to be to the left. If the area is more than 0.5, then A would be to the right. So x is less than A, so 0.378 is this area here, and they want you to find out what A is. So you would just plug that into the calculator. You go your second vase, 3 for inverse norm. Your area to the left is 0.378. Your mean is 23, and your standard deviation is 5. Enter, and you get 21.4 as being the upper bound. So that's what that little point there is, 21.4. Now let's do B. Probability, note this was x is less than A. Probability x is greater than A is 0.592. So remember, the area that goes into the calculator has to be the area to the left, but we were given the area to the right because it's saying x is greater than A. And we know A has to be to the left of the mean because this area is more than half, more than 0.5. 0.5 is this area, plus there's got to be another 0.92 here. So area to the left, it's easy, just do 1 minus this. So area to the left is 1 minus 0.592, which gives you 0.408. So this is the area that goes into your calculator. So you'll do this again, but you'll go second vase, and you'll put in the area, you'll put in 0.408 instead. Try that on your calculator. You should get the upper bound as being 21.8, which makes sense because your mean is 23. So 21.8 is to the left of that. That makes sense. This C one is a bit tricky, so that's why I've kind of got it all written in already for you. So probability that 23 minus A, that x is between 23 minus A and 23 plus A is equal to 0.427. So that's about like a bit less than half of the graph. So 23, notice, is the mean. So you can draw a sketch of it, draw your normal distribution, mark in your mean, and you can mark in 2 points. The lower bound has been 23 minus A, and the upper bound has been 23 plus A. Basically, they want us to work out what A is. So we know what this area is. And in a way, remember, like the normal distribution split in half. So if you want to work in just what this half of the area is, just divide this area by 2. So this area must be, oh well, basically what I did, I worked out what I'm going to try to work out what this upper bound is here to be able to help work out what A is. What's this upper bound here? We need to be able to plug in that area into the inverse norm. So you could think of this as being 0.5, 0.5, and then you could just do subtract half of that. What I did was I worked out what the whole unshaded area was, and I just divided it by 2. So the whole unshaded area must be 1 minus the shaded area, 1 minus 0.427. So these two shaded areas add up to 0.573, and I need to input just this shaded area. So they're equal in size, so I just divided this area by 2. So 0.573 divided by 2, the area that goes into the inverse norm on the calculator is 0.2865. So plug that into the calculator. Let's go second vase, 3 inverse norm. So we need to put in 0.2865, enter. Our mean is still 23 and our standard deviation is still 5. So what that has told us is that 23 minus A is equal to this number. So it's told us, and because we don't know, this upper bound is not A. If it was A, then 20.18 is our answer. But 23 minus A is equal to this answer. So let's write that as an equation and we'll solve it. 23 minus A is equal to the upper bound, 20.181 ... So to solve for it, I would suggest you would just add A to this side and then subtract 20.18. So go 23 minus 20.181 gives you 2.82, so A equals 2.82. This is an example of a much tougher question, but it has come up in a past exam before, and you might see one in the topic assignment possibly. So it's still worth taking that one in, and feel free to replay this question if you want. There's still one more page to go. And we'll whip through this. So see the information below for the fishing guard regulations in Bermuda. Minimum sizes and bag limits apply for certain species. They include black grouper, rockfish, 37 inches, 1 per day. Yellowmouth grouper, 20 inches, 1 per day. Lane snapper, 10 inches, 30 per day. Yellowtail snapper, 12 inches, and hogfish, 18 inches. So they're the fishing regulations in Bermuda. Let's say that the lengths of lane snapper are approximately normally distributed with a mean of 14 inches, so mean equals 14, and a standard deviation of 2 inches, so sigma equals 2. Find the percentage of fish which are under the allowed limit. So let's do a normal distribution sketch. Let's mark in our mean of 14. So let's see, lane snapper, the limit is 10 inches. So anything less than 10 inches, they would be considered under the allowed limit. You're meant to catch them if they're 10 inches or higher or larger. So under the allowed limit would be less than 10 inches. So 10's to the left of the mean because 10 is less than 14. So this little area here is what we're looking for. So we're being asked, remember, are we being asked to calculate an area? We're being asked to calculate an upper limit. We're being asked to calculate an area and to turn it into a percentage. So for that we need to do normal CDF. So go second vase, select the second one, normal CDF. What's our lower limit? And you might have guessed already, it's negative infinity, which I happen to have in there already, negative 1E99. If you forget how to do that, negative 1, second comma, to make E99. Our upper limit is 10. Our standard deviation is, no, sorry, I was saying our mean, it's 10. And our standard deviation, I don't think we know it, do we? Oh yeah, we do, 2, it says here. Standard deviation of 2 inches. Paste. So we get a weird answer. Very weird answer. Let's see, have I entered in the right amount to begin with? I'm not sure if I have. I think I've made a boo-boo. Let's go back. Second vase to normal CDF. Yep, -1 E99. Okay, yep. Our upper limit is 10. That's right, but our mean is 14. I didn't put in the right number. Our mean is 14, not 10. Sorry about that. So let's put the right numbers in. So this little area here is 0.2275 and so on. But don't forget to turn, they want it as a percentage. So to turn a decimal into percentage, you just times by 100. Times that by 100, you get 2.28%. So that was the percentage of fish which are under the allowed limit. Find the percentage of fish which are above the allowed limit. That's easy. So it'll just be 100% minus this little area here, 2.28. 100 minus 2.28% gives you 97.7%. That's the area below, that's for the area above the legal limit. So Lauren catches 30 fish that day. How many do you expect she will have to throw back in the ocean? So if she throws them back in the ocean, they're below the limit. So below the limit is this area here. Don't use the percentage, just use the probability. Take the probability, times it by 30. That's how you work out the expected amount. Probability unrounded was 0.0227 ... times 30. Gives you roughly 0.6825. So approximately 1 fish maybe, if you have to say a whole fish. So remember, when you ask to work out the expected amount, take the probability as a decimal and times it by how many fish in total there were. Last question. A fishing authority from another country says the smallest 10% of lane snapper, so 10% in area would be 0.1 because divide by 100. So the smallest 10% of lane snapper should be thrown back in the ocean, like this tiny amount. What is the size limit for that country? So this is a different country to Bermuda. So according to Bermuda, it was 10 inches. What is the upper limit for this country if they're saying the bottom 10% has to be thrown out? Assume the mean and standard deviation stay the same. So from above, you'll see the mean was 14, standard deviation was 2. So we're already given the area, smallest 10%. So the area to the left is 0.1. So we need to inverse norm. So let's go clear, second vase, 3 inverse norm. We're told that the area is 0.1. We're told that the mean is 14 and standard deviation is 2. Paste. Let's see, so our upper limit is 11.4 inches for this particular country, whereas the limit for Bermuda, according to this question, was 10 inches. For this country, it would be 11.4 inches is the upper limit. And so on. And that's the end of the lesson.